Okay, so this is what we have. Please work. I got this. Okay, all right. So this is what we're going to start off with. What I want you guys to do this first one together. Thank you, Danielle. We're going to do this one together. But what I want you guys to be able to do eventually is to draw array diagrams for all these. Now, this one is pretty straightforward. Here's my mirror. Like that. All right. And so this is the shiny part of the mirror. Right. And so this is me looking through the mirror at this object. Okay. And it's not really this object that I'm seeing in the mirror. It's the image of the object that I'm seeing in the mirror. Right. So the first thing we need to do is draw the image of this object. Now, the question is, how do we do that? Well, I want you guys to think of this. Yes. Yes. Tell me. Okay, that works if it's a dot, but it doesn't necessarily work when there's a 2D or 3D object there. All right, so we're going to, you're right, that works, but again, only if the object were just a small one dimension. They're not saying that we should extend the mirror or pretend that there's a mirror there and make it directly on the side. What he is right about is that it will be right here. The issue is how is it going to look like on this side, right? That's what we try to do with this. Right? Okay, so let's remove this. What I want you guys to do is imagine this object as two dots instead of one dot. And we can do it Danielle said, or we can do it another way. And I'm going to choose my dots to be one at the beginning of the arrow and one at the other end of the arrow. Okay? And if you remember, the way that it works for mirrors is if you have an object, and if you have a dot object, there's going to be rays that are coming out in all directions. And it'll be one dot at a time. Right? So if there are rays coming out of the object, let's draw a few of those rays. Right? So I have this one, this one, and I have this one. Right? I have many more, but these are the ones I chose to draw. Right? So this object, this dot object, just the tip of it, is going to shoot rays in all directions, some of which are going to hit the mirror. Now, these are reflected rays or incident rays? Incident, because they're heading towards the mirror. Okay, so if this is a flat mirror, which law do I need to obey in order to find the reflected angle? Yeah, it's the same angle. The law of reflection, I draw my normal line. Wherever my ray hits my mirror, I draw a normal line. Right, and this is going to be my incident angles. And I have to draw for each of them the same angle, but on the other side of the normal line. Right, so I'm going to try to do this, but I don't have a protractor, so forgive me if it's not perfect. Right, let's say. This is going to be that. That. Okay. These are going to be the reflective. Okay. That's just roughly speaking. Now, how do I find where my image is? How do I define the image again? It's where the what meet. What kind of rays do they need to meet in order to form an image? Reflected or incident? Yes, where the reflected rays meet, that's going to create the image. So here are my reflected rays. Here they're diverging, so converging is going to happen over here. So let's work backwards. Okay. Okay. Oh, this is horrible. Okay, I'm cheating, right? Oh, there it is. Somewhere there. Okay. Yep. Can you do what? When you extend the mirror, You could do that. The only issue with that is it's not really how the image is formed. This one actually talks about how the image is formed. You got what I'm saying? The reason why the image is there is because of this. Whereas if you were to just make it perpendicular, there's no physics behind that. It's just like, I know it's there because I know it's there. But to me, it's not as accurate. But it's not bad, though. If I took your method and I measured this distance here, and it's called as di, that would be the same as this distance here. Okay. That's just one tip. If I were to do the other tip, it would be somewhere there, and I end up with an arrow like that. Okay. That's how I get the image, though I don't know yet how I'm seeing it, because the observer has played no part in this yet. Okay. And the important part is how do the rays get to the observer's eye? And that's the important part. So that's how you get the image first. If you don't mind, can I erase this? Not yet. Okay, I'll wait a bit. I'll wait a bit. Okay, so when you erase all this, I successfully drew my image. Now I have to see how I see that image. All right, so again, we're going to take one point here, and we're going to work with that one point. And so if I'm the observer, I'm seeing the image. So the rays are going directly from the image into the observer's eyes. So you go from the image to the observer. And then that's another point to the back here. So I'm going to also take that point. You always have to draw the direction of the rays. All right. If you don't draw the direction of the rays, we don't know what's happening physics-wise in terms of where's the light going. All right, that's perfect. I see those rays coming into my eye. Is there a dot here in which I see its light as well? Yeah, I see that there's an infinite number of points in between the top of this arrow and the bottom of this arrow that are going to be doing the same thing. But if I do both extremes, I don't need to do all the ones in the middle. Okay, so that's why I chose the last point and the first one. Now, look, at one point it collides with the mirror. So I can draw a normal line there. That's what I'm going to do. Perfect. There's my normal line because my reflected ray hit the mirror. And I can follow the law of reflection because look, I got two angles now. I can follow the law of reflection to draw back the incident rays. And the incident rays should be bringing me directly to this object. So what I'm going to have is, that's the tip of the arrow. So this is going to go to the tip of the arrow. And this one's the top. Oh, yeah. Does that make sense? Yeah. This is your incident ray. This is your reflected ray. There's two of them. One, two. Is my image inverted? Yes or no? No, it's definitely not upside down. We know that from looking mirrors. When we look at a mirror, we don't see ourselves upside down. But is it flipped that way? Okay. Yeah, it is. So if I were to, let's say, if this whole board is a mirror, and I were to look at you guys, I would see the flipped image of you guys. And that makes sense. Look, this one is facing Sounds good. All right. So here's what I want you guys to do. I have a bunch of markers here. Draw ray diagrams. I want you guys to draw ray diagrams for this situation. It looks the same, but it's very different. So try to do the ray diagrams for this one. Yeah? Come and get markers. Leave the blue ones for the red walls. Just walk there. It takes 2 seconds.
Because this one I catch.
Aí eu saio, colocar, eu faço, colocar, ele lá tá doido.
You can use that. It's the only one I have. You can use it. Pick a blue one if you're gonna run into the red wall.
Oui, peut-être ça doit faire comme ça. Oui, que ça va. Que ça fait. Woo! Woo! Nice. First try. Nice. The red one is first try. Ok, donc ça, en ce moment, je joue sur un point. C'est possible que ça va.
Okay, my
Non, parce que si tu regardes là, you can see it. Ça va pas. Non,
Just spend the same.
Tu ne vas pas le voir ici. Si tu vas dans le verre là, tu vas pas le voir.
Okay, but just do the drawing. Good. What can I say?
Not straight.
Whoa.
Nice. I use that foul lane.
Don't use that. It's for content.
Yeah, where's your rapporteur done, buddy?
So where did you get the angle from?
That's the normal.
Comment t'es calculé? Comment t'as mis ta normale? Celui que t'as mis? Exactement.
Just guess that it's straight.
T'as juste guess ta normale? Wrong. Hey, t'as-tu guess ta normale?
Wrong. Don't do that. It's way more. Comme ça? Yeah.
Hey, t'as-tu guess ta normale?
Wrong. Perfect. You buddy. What? Yo, what are you doing? No, it's fine. Where's that?
The normal is just on the left of the mirror.
Why would you do this in the class?
Because I'm not.
Oh,
Once you miss one, we're doing 2 things that might not have happened.
Oh, it's so gross.
Double mirror.
If I see this about it, teacher, it's like
You decide.
Okay, you draw your point. Yeah, you have another point.
I don't think Yara was a nut. But for the Irie,
Well, no, that's the tip.
what type of mirror is that? It's Irie, just for.
It's the tip of the arrow. Can I do the bottom of the arrow?
But the observer is not seeing anything yet.
Yeah, it's still at the end of the thing.
But it's not a dot, he doesn't just see a dot at it.
You have to see the whole thing.
Yeah, he didn't do the.
Je sais, il faut que je fasse le deuxième.
You can't just draw willy-nilly. How do you know that that's a red? How do you know that this is the direction? So if I mark it, do you know that
Oh my god. Now the next one. C'est pour ça que l'autre après, que ça, je vais What? No. Yeah, I do this the second time.
To the bottom now.
I think I can still see it. Could he actually? I don't know. Okay.
You can probably see it on.
Yeah, I appreciate where's this thing?
Yeah, but look, the mirror doesn't extend that far.
I think he was not supposed to see it, but
Why isn't that? Look, it's the tip is right here. It doesn't go that far.
He's gonna see that.
yeah, but if that
What if
one
it's
is
like
not
that far?
supposed to see it.
Okay, fine. Like here.
No.
The example is not supposed to see it.
If anyone has a touchscreen, you can do it directly on there. Or you can just go up to the board.
Yeah, we can do it on there directly.
Marcus sucks, though. Je vais juste faire le point le plus loin, actually, parce que c'est ça qui
Yo, tu sais que t'es Marcus sucks.
Yeah, but you can still see part of it. He said there's a touch screen somewhere and then they use it.
You can use the smart pen or whatever.
Yeah, exactly. But I think. And yes, most like 6 months of update for us.
Oh my god, là, comment je pourrais faire les...
Yeah, I'm gonna bring my book for you guys. You're gonna see my book and if you want to find the book and yeah.
L'année, ils sont tous posés en même temps.
Oh my god, je suis en train de dessiner sur la règle.
It's not even close. That's not even close.
Yikes, Daniel.
That is horrible.
That's so bad.
Est-ce qu'il voit? Il voit juste une partie. Il voit juste un point.
Imagine not using a protractor. Use your in-head protractor.
I should be like that.
Integrated brain protractor.
And this one too is wrong. This one too is wrong.
The third one's
Closer, but it's still wrong. Look at this angle. Yeah, so that'd be the tip of the thing. Now, if you use this.
Oh, thank you.
Yeah.
After we will be able to see.
No.
No. Yes. You'll be able to see it. If you were here,
Observers during
observer can't see the whole image. No.
Là, les deux points. Ouais, quand tu fais les deux points à la limite,
Ah,
tu
ouais.
le vois, tu fais
You put the arrows like that, and then you take from observer and you
Did you hear what I said to you?
Tu prends les deux
Okay, so you're gonna tell me
tu fais les lignes là, les lignes là, tu fais la normale, tu calcules l'angle là, tu fais
I mean, I was just thinking, that those seatbelts just
You can always see, you can always see here. You can always see from here. And then you can
the roof just have in.
yeah, that's it. Yeah, so this.
You might understand, but what about this guy?
You put a point here and here, you bring it to the opposite eye.
Right.
And with the normal, you take this angle and put it here, and that angle you put it here.
Okay, what is that trying to do?
So this would be his shot.
Everything that is in the champ vision, you can see it when you're outside, you cannot see it.
Alright, so now you guys need to do the next one. Where's yours?
This marker is worthy for the garbage.
That's the next one?
Yeah.
Oh, j'aime ça. Ah, guys, on fait celle-là. Wow, this one is cute, dude.
Alright, if you're done, I want you guys to consider this next question here. This one's not easy if you've never done it before, so just keep trying it. Here's your two mirrors this time, and your mirrors are at 90 degrees from each other. And that's your observer and that's your object. I decided to make it simple and give you a dot object, but I could just as easily have given you an arrow object. All right, you're going to try to draw the same thing. Try to find the images and see how you see them. Okay, go. The marker doesn't work.
That is imprecise.
Is it approximative?
So it's not even, yeah, it's not even.
12, 24.
My bad, boys. Et on est là.
Je vais mettre à transit. C'est bien. Donc là, est-ce que tu es capable de voir? Je sais pas si les gars, ils devraient pas voir les nombres. C'est ça, regarde.
But, yeah.
Mais
If you aren't following or contributing, then you're doing nothing.
Est-ce qu'il est obligé de regarder par ce miroir? Il peut le regarder dans ce miroir-là.
Or you can look at it in both mirrors.
Ouais, tu peux. Là, si ça fait ça, ça va être genre. Attends, c'est où? Ça vient là. Ça va pointer là, puis ça va pointer là. Là.
Pick one. Do the other one. You pick one of these, and then
Ah non, j'ai compris. Ok, c'est pas.
What do you champ vision?
What are you guys doing now?
Ça va faire en fait sur Non, non,
I think if you go here, it's gonna go into the mirror.
non, c'est vrai, il va le voir là. Ça, c'est une façon de voir le. C'est une façon. Donc, comme ça. La deuxième façon, c'est.
C'est pas ce miroir-là.
Non, c'est par ce nom-là.
No, you don't see. Would you be able to see it? Yeah, you'll be able to see it.
If you look at the
That's it.
La troisième façon, c'est avec les deux miroirs maximum.
Let's do something fancy.
You want to bounce the ray off
I can just bring a book. Would you be able to like?
Si tu passes une image à l'autre. Ça pourrait se faire. Mais actually, je pense que c'est honnêtement, je pense que c'est ça qu'il faut que tu fasses.
You have to bounce it like.
Ouais, mais ça, si tu passes d'une image à l'autre comme ça, ça va donner une ligne
normal.
blonde. Ça donne une ligne blonde. Donc là, ça fait comme ça, puis comme ça.
I remember.
Oui, mais l'affaire, c'est que ça connecte dans le miroir.
Yeah. I remember how we did.
Non, on peut baisser. Il devrait, sur ce deux points-là, ça devrait passer dans le miroir. Donc, tu fais la ligne dans le miroir. L'angle de
Yeah, I remember. Yeah, I remember. I remember.
Mais je pense que c'est ça, comme ces points-là.
When you're doing the double flat here, my recommendation to you is first to draw your images. Start by drawing your images, then start writing
But
down
it's the
all the
one
observers.
you show the whole time.
Can't do where the observers
Isn't it?
see unless you make it first.
Oh, la face, je pense que
It has to be.
There's another template.
Yeah, it's somewhere here, Donald.
une image.
Yeah.
Yes.
There's another template.
Dis donc, image de.
Yes.
Non,
That's
non.
how it works.
Image et
Try and côté zéro.
Yeah, that's what I'm
Oui, mais after a double flap here, so you're not.
Well, I don't know what you mean by that, but
Because one of the images reflects.
Oh oui, 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 non, c'est ça, oui,
Double flap here.
I know where.
what you guys are doing.
Yeah, exactly.
donc ça c'est, ok, donc ça c'est le
You
cinquième,
can
le
do the
cinquième
same thing.
tu fais de
Instead
là,
of 90-degree mirrors, you have,
après tu fais à l'image là,
Yeah.
après tu fais là.
you,
Alright, that looks good.
Like this.
Is it 80 degrees?
hold on, but show me what you did. You just drew lines. I don't know what your lines are. You do this to me on a test, like it is zero. Not only is there no arrows
Okay, continue
on the
there.
green line.
You just go by hand. That's the way I like it.
Okay, now it's better, but what about direction? Where's your, what about angle? That's the only thing missing is actual. Okay, perfect.
Okay.
So if you all understand this, I want you guys to redo this. Sometimes there's me a 90 degrees.
C'est la même affaire, c'est la même affaire, mais genre,
Hold on, give me a second. You're under 45, you're gonna be 45.
non, ça va être dégueulasse.
You,
You don't have another 60, like? Oh.
60 degrees, yeah.
Non, c'est ça.
So, done?
Okay. Peut-être la affaire, juste que le.
This one is on that side.
C'est pareil, genre, différent.
Object,
Ouais,
and then
peut-être la
I
même
think this
affaire.
distance, yeah.
C'est la même affaire. On va juste slightly off. Ouais, ça, il va y en avoir un là, tu vas en avoir un là, là, celui-là, tu vas l'avoir là. Ça, c'est trois images. Ouais, mais on va dire aussi que c'est trois images. Donc, c'est la même affaire.
Yeah.
C'est ça qui décide. Genre, pour voir cette image-là, tu regardes là, ça va être là. Donc, comment ça fait affaire? Tu regardes là.
The only thing Daniel doesn't understand is that he does it like in high school where you can just assume this is here because it's here. So therefore you can just do it there and then it pushes from there.
I mean, isn't that kind of...
Now the teacher wants you to literally do some random lines like this.
Yes, but no, it's...
Non, mais c'est la même affaire. Genre, l'affaire, c'est la même.
I just think it's
Oui, mais c'est ça, les lignes qui sont faites, c'est enfin, genre, il est là, il est là, il est là.
He's gonna ring on every sound by bar.
that's why you
Oui,
It doesn't say fast. It doesn't say...
là.
yeah.
Voilà. Oh. Ouais, parce que tu sais, il était pas exactement là, j'en fais là. Mais ça veut pas, il n'est pas comme il est pas là. Mais jusqu'à la fin, ton miroir va pas être comme ça, ton tunnel va pas être là. Il est comme ça, ça va. Vraiment approximativement. Là.
So first of all, how many images
Ah, ben, il y en a une quatrième. Il y en a une quatrième, là. Là, c'est there for. There are, il y a trois. Non, parce que c'est expensive. Oh my god.
But then that one would reflect again.
Non, ça c'est le base de
Yeah, I don't know. No, I don't think
No.
Yeah. You know, I here. You are the. You are. So you need to make sure to make the light down there.
what's 360 divided by 80? It's something like that. What's 360 divided by 90? I gotta work my with something. There's 5. Daniel, in a sense.
No, 1, 2, 3, 4, 2, 3, 4, 5. This one.
There's 5.
No, you send it back.
Daniel, in a sense. Daniel, in a sense. Daniel, in a sense. What's the fifth one? Oh my gosh.
Hello?
I don't know what. Close enough.
Okay. I'm gonna ask you to the back. Thank you. And seats for 5 minutes.
How many?
I told you.
Degree pizza. And then here's your object. Everything is.
I told you guys. Like 4.
Okay. There's one measure object. And then there's 1, 2, 3, 4, 5. I don't know. How many sections would I do? 8. All right. Brown object there. Oh, there's no line there.
There's no line there.
Yeah,
One part. Here, where is it?
You have one here. You have one here. You have this one. This one.
Oh, it's this one. It's the reflection of this one.
3 lines.
So it's no.
Okay, so we're gonna do this one together because I want to make sure everyone knows it. All right. So the you is you're going to draw your images. So you know that there is if you look over here, there's a mirror, and there's going to be a reflection of that object in this mirror, so you're going to have an image approximately there. I'll let you guys do the ray diagrams or use Danielle's trick to find out exactly where it is. I just estimated it. And there's also going to be a mirror here, so that this object is going to get reflected in this mirror. You're going to have an image there. So you have to remember that the distance of the object, the DO, has to be equal to DI in terms of value, right? So it's going to be the same distance on this side of the mirror. So that's going to be roughly there, right? However, that's not it. If you were to look at this mirror, for example, you would see two things in that mirror. You would see the reflection of this object, and we drew it. But there's another object in this mirror. What's the other object? It's this mirror. So you have to draw a reflection of this mirror being reflected in that mirror. You're going to have a mirror like that, right? And that's a virtual mirror of this mirror. Similarly, if I look in this mirror, I'm going to see an image of this mirror. So I should have another mirror here. Like that. And so now I'm operating in the virtual world here, because I'm no longer, this is like the physical world, this is the virtual image world. I have this virtual mirror, and I have this virtual object. The virtual object is going to get reflected in the virtual mirror to create a virtual object kind of thing. All right, it's an image of the image over there. Okay, so I created there's three images being created. Now you might ask me, what about the reflection of this object in this mirror? What do you think it's going to be? It's going to be the same as this one. Okay, so they fall in the exact same spot. Okay, so if my mirrors are at exactly 90 degrees, I'm creating three images. Okay, all right. Now we have to look at how we see these things. All right, so if I were to draw this one to the observer, it's very straightforward. We'll do one example of it. So let's go like this, straight. Ugh, that's really bad. That'd be straight to the observer. All right. And by the way, is this a reflected ray or an incident ray? This is a reflected ray. All right, so I'm going to draw an R next to it. And so this reflected ray, look, it starts from a mirror. There's a mirror that's blocking it. So that's perfect. So that means there I can draw a normal line. And after I draw my normal line, I can draw my incident ray with the same angle. Where do you think my incident ray is going to go to? It's going to go to the object. It's going to go directly to the object. Oh, so it's going to go like this. Bad drawing again. Like this. And you can see that my angles are roughly the same. That's a pretty good approximation. So that's how I see this object. All right, and I might be able to tell you, draw me the ray diagram when you're looking at this object. And this is what you would draw for me. All right, not that simple, however, because I might not ask you about that one. I might ask you about this one. How do you see this object, or image rather? How do you see this image? The steps are the same. All right, the steps are, well, draw the ray directly to your eye. That should always be your first step. All right, and let's do that right now. I'm going to draw the arrow. Ah, no! I lost everything. Oh, well. Sorry, guys. I'm going to have to just restart something real quick. Oh, it's going to glitch. Oh, no. So here it is. I'm just going to redraw it real quick. Image here. Okay, so again, I'm going to go straight into the observer. That's the first step. Is that a reflected ray or an incident ray? Reflected. One thing you need to always remember is that you're never shooting beams out of your eyes. Beams are entering your eyes. Okay, so if it's going to the observer, that makes sense. But the observer is shooting beams out of its eyes like a cyclops. All right, so this reflected ray that's coming into your eye hits a mirror, right? A physical mirror, a real mirror, right? So at that point, we can draw a normal line like that, right? And let's draw the reflected angle. That's there. And if I were to follow the law of reflection, I would have to draw it on the other side. And it just so happens that if you drew it exactly right, it would also go to this point. Like that. And this angle here should be equal to this angle. That angle should be equal to this angle. And if you work back, it would also hit that object. All right? But holy crap, look, there's another mirror and it's touching the mirror again. So we have to draw another normal line. Like that. And if this is a, what kind of ray is this? Reflected or incident? It's reflected because it's reflected off of this one. But look at that. It's incident to this one. So the reflected ray here is going to become the incident ray here. Right? And so I can work my way backwards. And if I do it perfectly, these two angles should be the same. These two angles should be the same. These don't necessarily have to be the same to each other. So this one could be 60 and 60, this one could be 30 and 30. It all depends on the situation. All right, but the point is that that's going to be the incident reflected, and this reflected becomes the incident, and then it gets reflected again. Okay? So that's how you would see the object in two mirrors. Make sense? I also have to remember the reflection of the reflection. What's the angle between my mirrors here? If I had them at 60 degrees from each other, how many images will I see? Think about it. I know you guys know it. Don't say it yet. If you had your mirrors at 60 degrees, how many images will you see? I want you to use this to help you. Because look at this. This one is 90 degrees. All right. And I want you to visualize this kind of like a circle that I cut into 4 sections. And therefore, there's 3 images because one of the sections is occupied by my actual object. So if it was 60 degrees, figure out how many sections I'd be cutting it into. I'd be cutting it into 6 sections. One of those sections is going to be occupied by my object. And so therefore, how many images do I have? 5, exactly. So what's the relationship here? Try to find me a rule that determines how many images I'm going to create based on the angle between the mirrors. Just kind of say like that. I don't give the others a chance to kind of think about it. So if you think about it here, I divided it into 4. So how do I divide 360 to get 4? I use the angle, 90, right? So it'd be 360 degrees minus the angle. And then I told you that one of them is going to be occupied by the object. So I subtract 1. That's going to be equal to the number of images. Okay. All right. Let's move on because now we're going to do double lenses. And that's no easy feat. All right. This one's a bit trickier. How are we doing on time? Perfect. This is going to help us with our telescope activity later on. And the trick here is, how should I start this? Let's point out the fact that the observer is here. Okay, that's important because it's going to help us in sign convention later on. And I have my object here, right? And I have two lenses. What kind of lenses are these? Convex or concave? Yeah, these are biconvex lenses, okay? The focal point is written here, and the focal point is written here. This F1 is the focal point of this one, and that makes sense. This is F1 and F1. But why I'm going to go with that one first is because if I have an object, the rays are going to hit this lens first. All right, and here's what I want you guys to do. Knowing which lens it's going to hit first, let's draw the ray diagram for that lens. Okay, ignoring the fact that there is a second one altogether. Okay, so we're going to draw the ray diagram for this one. You guys remember the 3 rays that we need to use? Tell me which ones they are. Okay, so let's start parallel to the focal point. Parallel into the focal point. Next one. Focal point to parallel. This is not going to work. Okay, and then through the center, straight across. Not bad. All right. All right. So that means that ignoring this lens here, my object was formed right here. It's inverted. It's real or virtual? I need more people to say whether it's real or virtual. It's real. It's a real image because it's supposed to be on the other side of the lens, right? If it were on the same side of the lens, I wouldn't. And inverted, smaller or bigger? Slightly smaller. Okay, perfect. And what I want you guys to do is use your equations now. Remember the equation is 1 over di plus 1 over do equal to 1 over f. I want you guys to figure out what the di is here. Okay? So go ahead, calculate that for me. Give me a number. Do the math, write it down. So I'll write down the numbers while you guys are doing it. 1 over di is equal to is plus 1 over do, which is 50 centimeters, equal to 1 over f, and f is 20 centimeters. You guys expect a positive number or a negative number? Positive, because we said it's a real image, right? You guys got 33.33? $33 centimeters. All right. That makes sense because look, the distance between the two lenses, 25, and it goes just beyond that lens, so we know where the image is going to be with respect to this other lens here. Now, what's the distance between this lens and that image? How much? Yeah, well, if it's 33 up until here and 25 up until here, well, you just do the difference. You can find what the difference is, what the distance is to that mirror, to that lens. So that this section here is going to be 8.33 centimeters. Okay. Now we just need to redo this calculation, all right, to find out where the new image is going to be, because now this becomes the object in the new lens system. Make sense? All right. Let's go ahead and do it. So it's going to be, now I'm going to do this part in blue. So 1 over di plus 1 over do equal to 1 over f. And we said that we're using this f2 lens now, so I'm going to write the f2 here. And this has a focal length of 10 centimeters, so it's 1 over 10. And 1 over do is 1 over 8.3. So what's going to happen then? Okay? Well, figure it out. Where does it go? Tell me exactly. What's DI? What'd you get? Minus what? Minus 50? That's a big number. So where is the image, in fact? All the way over here. Right? So if it's 50 centimeters away, it should be somewhere here. Is it going to be bigger or smaller, you think? Why? Yeah, it's going to be bigger. Not because, well, yeah, the rays are going to go all the way down for sure. But the reason why it's bigger is because this object is within the focal point of a convex lens, right? So if it's within the focal point of a convex lens, think of a magnifying glass. A magnifying glass will make something look bigger if you're very close to it, right? The magnifying glass will make something look bigger, and it does not change its direction. So if it's downwards here, it's going to be downwards there, right? So far, so good? Okay. All right. This is the idea behind a telescope. All right. And it leads me into the next section, which is talking about optical instruments. Essentially, you want this final magnification to be as big as possible, right? Because that's what you need to do when you want to see something that's very far away. Or if you want to see something that's very small, it's also the same concept as a microscope. You want this object to appear as big as possible and as close to the observer as possible. So we're going to play with these two ideas. Yeah. It'll be smaller and inverted. It'll be smaller than this, and it'll be right side up again. Yes. Yeah. In both cases, the observer will be able to see it. And I'm going to show you guys how that works exactly. So please take out PowerPoint number 12. Okay. So let's figure out how these things work. It's actually pretty simple. You know, you look at this gigantic thing, and you're like, oh my God, the stuff inside there must be so complicated. But in principle, it's actually really not that complicated. There are two lenses, all right? There's the objective and the eyepiece. All right, which one's the one that you look through? Yes, the eyepiece. That's what you put your eye. All right. So that means, let's say we're talking about the most simple, like Pirates of the Caribbean type of telescope where you just kind of like do this. You know that one? Know what I'm talking about? That's what we're going to be building upstairs. Okay, it's going to be a very simple two-lens telescope, which you're going to be able to change its focal point by changing the distance between them. All right. So there are two lenses, and we're going to see how they work. Just real quickly, there are going to be two types of telescopes. The refractive one, which is what we're going to talk about right now, and a reflective one, which is what most of the Hubble telescope type telescopes are. So these are called these refractive telescopes, the ones that use lenses. They're actually called astronomical lenses or astronomical telescopes. And the idea is that you have a two-lens system, right? And what you want to make sure is that the focal length of this one here is at exactly the focal length of this one here. All right, so if I have two lenses, let's say, I have a blue marker. So if I have a lens here, and it's 25 centimeter focal length, and I have another lens here that's a 5 centimeter focal length, how am I going to place them so that I can achieve that exact result? So here's my 25. So there's going to be, what's going to be the distance between the two? 30, exactly, because I'm going to want this to be f1 and this to be f2. So I'm going to add the two focal lengths together, and that's going to be my second length. So my 5 centimeter focal length falls exactly on the 25 centimeter focal length. And the distance between the two is 30 centimeters. Or you can just say f1 plus f2. Okay? You want that to happen for your telescope to be able to see something with nice resolution. Now, what do you notice about the rays coming in here? There's a ray there, a ray there, a ray there. What kind of rays are they? They're incident rays, yes, but what could you tell me about the way they're coming in? Imagine that this is the principal axis here. What can you tell me about that ray there, that ray there? Yeah, all of these rays are parallel, okay? So when you're looking at anything, it's impossible that every single ray is parallel, right? Because if I have an object right here, if I have an object right there, my ray is going like this, like this, like this, like this, right? Up, down, straight, whatever. But they're not all parallel, so this object can't work. When you're looking through a telescope, where is the object that you're looking at? It's really far away, really, really far away. Right, so let me just draw you another diagram. So here is an object. I'll make it a bit bigger. And this is some point. Let's just call this the length, right? So we have this ray that's coming in at that angle, parallel. So that one is going to be parallel through the focal point, through the lens, and through the focal point, and then parallel. Okay, that's at this distance. But if we were at this distance here, all right, all of my rays would almost look exactly the same, right? So here's my parallel one. All right. This is going to be the one that goes to the center of the mirror. And this one's going to be the one, they're not straight at all, but I hope you get the idea. This is the one that's going through the focal point. Now they're more or less parallel. They might not have seemed parallel here, but once you get here, they look more and more parallel. And this is not even that far. It's only like 4 meters, right? So if I'm looking at, the moon or the stars in the sky, they're super duper far. So all the rays that are coming from it are parallel. So the rays that are parallel to the lens, where are they going to bend to? If all of the rays are parallel, they're all going to refract towards the focal point. So all of these rays coming in are parallel, they're all going to converge on the focal point. Follow what I'm saying? And that's exactly what's happening here. Look at all the rays coming in parallel, and they're all being focused on the focal point. Has anyone ever played with a magnifying glass burning things? No one? Just maybe Danielle, I know him. Anyways, you can use a magnifying glass to burn something, and what you're doing actually is you're focusing all the light from the sun, because you use the sun to do this, you're using all the light from the sun to converge into a point. And where does that point? Is the sun far away? Yes, the sun is super far away. It's 8 light minutes away, so 300,000 kilometers multiplied by 60 multiplied by 8. And that's the amount of kilometers away. So yeah, it's very far. And so all the rays are coming in parallel, and then when they hit the magnifying glass, they converge and they meet at the focal point of the magnifying glass. All right, and that's why you see a point. And when you get that point, that's when you start burning things, because it starts to concentrate all the rays into that one area. Just on a side question for you guys, if I had a bigger magnifying glass, would I be able to create a higher temperature by burning something? Why? Yeah, I have more ray. I'm capturing more of the sun's energy and focusing them onto one spot. All right. So imagine like you're supposed to get 10 and you're lying in the beach and all that sun rays hitting you all over. And if it were to all of that energy be focused onto one point, that would make that one point a heck of a lot hotter than your entire bronzing body, right? You guys get what I'm saying? So the bigger the magnifying glass, the more energy you're concentrating. Same idea works for telescopes, right? So here's my telescope, right? If I really want to get all the light incoming from the stars, then I need a really huge big lens here, right? That's one of the reasons why telescopes can't use lenses, because they don't make lenses that big. Making a lens humongous, like the Hubble telescope is humongous. It's got a radius of like a few meters, right? And to capture the amount of light, you would need a lens that big, and building a lens or manufacturing a lens like that is nearly impossible. It's fragile because it's going to be thin at the edges, and you have to transport it. It's super heavy, so they'll use mirrors instead, and I'll talk to you guys a little bit about that later. So I'm just going to erase this real quick. What happened to my eraser? Can you just toss me an eraser? Good. Oh. All right. So in this case, it doesn't really show very nicely. I don't know why it's all dark. Okay, here is better. So here you have the objective lens, and here's the eyepiece. And what's going to happen is you're going to focus all the light into the focal point, and it's going to flip the image around, and you're going to see an image of it in your eye. Now, the nature of this is that you're going to see the image upside down. So if you were to use this kind of telescope, whatever you're looking at, it's going to appear upside down. That's okay. Take a picture of it digitally and just flip it around. Again, we talked about this. So this is going to be the major slide that you guys need to understand. That's going to take a while, actually. Let's go make a telescope. All right, so I'll explain this next class. But what I need you guys to understand for when we go upstairs is you don't know exactly how far the object is. Right? So it's not going to be, what you're going to build is not going to be good enough to see the stars. It might be good enough to go see the cars in a little bit more detail, right? So we're creating a glorified binocular. You need to listen to this part. In order to create, if you don't know the size or the distance of what you're looking at, you need to be able to vary the distance between the lenses. Okay? And varying the distance between the lenses can happen, or if you remember, the pirate does this, right? So you guys are going to have to do something that is able to go further and closer together depending on the distance of what you're looking at. The objective is probably the best. Okay, I'll get back to it. The objective of today's class is I want you to take a picture through your telescope with your cell phone. Show me the picture. You can do that, you're ready to go, and I'll let you go home after that. That's what you need to do. You can't take the telescopes home because I need to recycle the lenses for this afternoon. Okay? We're gonna go in the chem lab. Hold on. We're gonna go into the chem lab. The material is there, however, the lenses are being shared with the other physics group. So we might have to go into the other, into the physics lab to get them. Just be respectful, don't sit there and chat with the other students. Yeah, take your stuff and don't come back here.
Questo